Welcome back to C23 Classroom channel, and I would like to share with you example to solve turbulent boundary layer by using the empirical method. So let's say we try to estimate the boundary layer thickness at the end of a 4.5 meter long flat plate if wind flow on it at 30 meter per second, and also calculate the drag force on one side if the plate is 3 meter wide. Use the empirical data. Assume that the temperature is 20 degrees Celsius. So for this question, we know that it's talking about wind and it gives you temperature is around 20 degrees Celsius. So what you need to do is please make sure that you know where to find the table for the properties of air at atmospheric pressure. So we look at 20 degrees Celsius here, so means that please bear in mind that we need to use all of these properties. So means the density is 1.204, the dynamic viscosity is this one, and this is the kinematic viscosity, and so on and so forth. Okay, so the question need to calculate the boundary layer thickness. So the only equation that we have for the empirical method is this one. So we have the terms delta here. So we need to calculate what is the value of this delta. However, previously we need to calculate what is tau, U shear stress. So from the previous lesson, we know that U tau is equal to tau naught over rho, and tau can be calculated by using CD times 1 over 2 rho U square. So CD here is the local friction coefficient, and CD can be simplified into 0.455 over ln 0.06 Reynolds number square here. So first we need to calculate the Reynolds number. So this is the equation for Reynolds number. We have rho ux over mu or ux over nu. So again, please differentiate between the dynamic viscosity here and kinematic viscosity. So it's depend on you. Any equation is correct to calculate the Reynolds number. So let's say I use the kinematic viscosity here. So I found that Reynolds number is 8,900,000 is this one. And then the value of ln 0.06 Reynolds number is 13.1926. So I substitute in the equation of tau naught here, so I get around 1.416 Pascal. And then we calculate the value of U shear stress here. So according to this equation, we will get around 1.084 meter per second. So we substitute all this value, the value of U shear stress here, U tau, and the kinematic viscosity here, the U tau here, and also the value of free stream velocity can be replaced from the table and from the question. So we could calculate this one. So this is the very basic mathematics. I will not show it here. So we could find that the delta is equal to 0.066 meter. So please bear in mind that delta, the boundary layer thickness, is the actual thickness that occur on that plate, and it can be measured from the experiment. So mean the thickness here must be in length unit, which is meter or microcentimeter or millimeter. And to calculate the drag force here, we have the equation. So this is the equation to get the CD. We substitute with all the data that we have, and finally we could say that the total drag force here is the total drag coefficient is 0.03. And then this is the common equation to calculate the drag force, CD times 1 over 2 rho AU square, and then we substitute with all the parameters. So we could say that the drag force occur on that flat plate is 21.94 newtons.